Okay, welcome everybody to our latest seminar for the U.S. Society of Ecological Economics. As you know, we took a few months sabbatical from seminars, but we'll get started again. And we're very fortunate today to have Vicky Heijnk. Hopefully, I got that kind of close. Uh, she's a, PhD candidate at the University of Hohenheim, and she's done some really interesting work I came across. We're so glad I reached out to her, and she was very willing to present, and we're so grateful to her. And with that, I will turn it over to you and make sure that you have the ability to share your screen.
Yes,
Sorry
I
about
would
that. I
do
should have
that.
done that before.
No worries. Mm, let's see. So probably you can see my screen right now, right?
Yes.
Yeah, okay, perfect. Okay. Yes, yeah, thanks for the introduction and also for having me. I'm really excited to be here and share some of our latest results with you. Yes, so every year households waste billions of kilos of fruits and vegetables, and that's not just a waste of calories and nutrients, it's also a waste of money, water, and greenhouse gas emissions. And reducing food waste is therefore not only a moral challenge, but also a key sustainability goal. So it's also explicitly mentioned in the United Nations Sustainable Development Goals. But at the same time, especially now during food price inflation, affordability and food security are hot topics. So in Germany, for example, there is an ongoing debate about whether the value-added tax on fruits and vegetables should be abolished in order to promote healthier diets. So currently we have a 7% value-added tax rate, but it is discussed to reduce it to zero, actually. But the question is, what if such a policy had an unintended side effect leading to even more fruits and vegetables being wasted? And yeah, this is the question I asked myself a couple of months ago. And yes, as John already said, my name is Vicky Heijnk. I'm a PhD candidate at the University of Hohenheim. And together with my supervisor, Sebastian Hess, I set out to explore this research question. But yes, so let's start from the beginning. So, worldwide, and every year, 1.3 billion tons of food are wasted or lost. And in the developed world, the majority of food waste is generated in private households. And within these private households, the majority of food waste consists of fresh fruits and vegetables. And yes, as I said, in view of a growing world population with like nutritional needs, but also with respect to resource scarcity and climate change, I think it's obvious for us all that food waste is problematic and should be reduced. Also, as I already said, within the United Nations Sustainability Development Goals, the target 12.3 was formulated, which declares that food waste should be halved by 2030. In the last years, we observed an enormous increase in public attention, but also in research on food waste. And this research focused particularly on the quantification of food waste, but also on factors that influence food waste generation. However, we realized that one aspect has received relatively little attention, namely the effect of food prices on food waste. And yes, given that prices are known to play a crucial role in consumer decision, it seems reasonable to assume that also prices somehow might affect food waste generation. So a research hypothesis could be that food prices have a negative effect on food waste generation, that is, decreasing food prices lead to more food waste. And corresponding empirical insights on such a relation would have important implications for policy or market environments that influence food prices or aim to reduce food waste. And one example, which I already mentioned, is the removal of the value-added tax rate on fruits and vegetables to promote healthier diets. Because despite the potential positive effects on health, one could ask whether and how such a policy might affect food waste generation. However, we realized that empirical research on this relationship is sparse and inconclusive. So therefore, we aim to address this research gap and estimate the effect of food prices on food waste for fresh fruits and vegetables. Yes, so for our work, we used data from a food waste diary study titled Systematic Monitoring of Food Waste from Private Households in Germany, which was commissioned by the German Federal Ministry of Food and Agriculture and carried out by the GfK. And within the study, the participating households were asked to record their household food waste for 2 weeks within a designated month. And the months were assigned as such that a balanced distribution over all calendar months was achieved so that we can capture seasonal effects. And then we had 2 waves. So a first wave was conducted in 2016-17 and a second one in 2020. And so for us, for our study, the most important and included information were that the households reported wasted food amounts and that the households assigned the food waste to a predefined food item and that they indicated whether the food waste was avoidable or unavoidable. So unavoidable means that it is inedible, like for example, banana peel. And avoidable means that at least at some point in time it would have been eatable. So this is the distinction they make, and we concentrate on avoidable food waste. Just a short comment on the data collection procedure. So we are aware that this kind of self-reported data comes with some inaccuracies and potential biases. However, alternative approaches of food waste data collection also have disadvantages. And also the use of food waste diaries is quite established, but nevertheless, one should keep these inaccuracies in mind when evaluating our results. However, so we assume that the self-reported food waste data is least prone to observational bias for perishable food items, like, for example, fresh fruits and vegetables. And in addition, fresh fruits and vegetables are, yes, as I already said in the beginning, the main component of food waste in terms of weight. And fruits and vegetables would be directly affected by this value-added tax reduction on fruits and vegetables. So therefore, we decided to focus in our work on the recorded avoidable food waste amount in grams of fresh fruits and vegetables. And then we have this amount per household and per food item. One problem was that the data set unfortunately didn't contain information on the food prices, which were actually paid by the household for the wasted food items. So we had to proxy the prices. And yes, so to proxy the food prices, we assigned monthly price data from the Consumer Price Index of the Agricultural Market Information Company. And then we assigned these prices, these monthly average prices, to the food items from the food waste data. So we have like conventional non-organic food prices. And as I said, they are an average across German regions, but also across all types of retail stores we have. And then we try to match these food items from the food waste study with the food items from the price data. And by doing so, we realized that, especially compared to other categories, this assignment of price data to food waste data was relatively straightforward for fruits and vegetable food items and was less straightforward for other food categories. So this was another reason for us to decide to focus on fruits and vegetables only. So yes, unfortunately, we were unable to use the exact or the actual prices households paid for the fruits and vegetables, and we used the monthly average prices as a price proxy instead, which involves, of course, some inaccuracies. But of course, it also has an important advantage because it helps us to avoid a potential source of endogeneity, the price quality link. So you can think of it this way. So lower quality fruits and vegetables are usually also cheaper, and cheaper food at the same time is more likely to be wasted. And therefore, because we cannot control for the unobserved quality level of fruits and vegetables, this could bias our results. And when we use these regional average prices instead, which was inspired by Hausmann actually, we reduce the risk that differences in food quality drive the estimated effect of food prices on food waste. Okay, so back to our final data set. So overall, we have 20,204 food waste observations, and these food waste observations come from 6,696 households, and we observe food waste for 35 different fresh fruit and vegetable food items. And as I already said, we have data from two waves, and each wave has an observational period of 12 months. So therefore, we have up to 24 monthly price observation for each of the 35 food items. So in total, we have 746, I call it food time combinations. So for example, one food time combination is apples in June 2020 or tomatoes in January 2017. And yeah, they have corresponding different food prices. So 746 is not exactly equal to 35 food items times 24 food price observations. And this is just because some food items, for some food items, we do not observe the prices in some months due to, for example, seasonality. So this is just a side note on that. Okay, so a peculiarity about our data is that we have a crossed data structure. So this cross data structure is illustrated here in this graph. And so, for example, we have one observation, and one observation is, for example, 120 gram of avoidable food waste. And then we can attribute this observation to one household. Here, for example, the household with the ID 76. And at the same time, we can attribute this observation to apples in June 2020, which in turn belong to the broader category of apples in general. So we have the households as one unit of observation, and then we have the food items as another unit of observation, and therefore we have a crossed data structure in the sense that yeah, we can say that each of the 20,204 food waste observations belongs to a combination of one of the 6,696 households and to the 746 food time combinations, which in turn are nested in the 35 food items. And yes, so this cross data structure need to be taken into account explicitly to obtain more accurate inference.
Vicky, something happened to your audio.
Ah, okay.
Now
I
we
didn't change
perfect.
someone. Okay, you can still hear me. Okay, great. Yes, okay. I hope that you got the sentence before. But yes, back to our model. So we estimate a mixed effects model based on a maximum likelihood estimator, which combines fixed effects and random effects, and it looks like this. So we have on the left-hand side of the equation our dependent variable, which is the aggregated avoidable food waste amount per household and per food item in grams. And by the way, we also estimated a model in calories, but the intuition of the results was more or less the same. So therefore, right now I focus on the gram-based model. And then we have on the right-hand side our fixed effects first. So we have some household characteristics. So we have the age group, and we control for the highest level of education. We have an urbanity dummy, the household size, and a dummy for children under 18 in the household. And then we also have variables related to the food time levels. So we control for whether the data was collected in the second or in the first wave. Then we have the months. Then we have a dummy for fruits versus vegetables. And last but not least, we have the variable of our main interest, the price variable. And yes, just for our statistical analysis. So we performed a logarithmic transformation with the price variable, but also with our dependent variable. And yes, overall, so we tested several model specification against each other, and it turned out that this specification with random intercepts, um, yeah, is the most appropriate one. So we have random intercepts for the household, and then we have random intercepts for the food time combinations nested in the food item and for the food items. Okay, so this is the general model specification, but then we realized that we actually have two kinds of price variation in our data. So as I said before, we have 35 different food items, and we have food item specific monthly prices for up to 24 months. And accordingly, we observe two kinds of price variation. So I try to illustrate that here in this graph. So on the one hand, we have price variation in terms of price differences between food items. So we have here in the graph the monthly mean prices on the vertical axis, and on the horizontal axis, we have the months of observations, and in green, apple prices, and in red, prices for raspberries. And the dashed line here is the mean price for raspberries and here for apples, respectively. And yeah, so when we compare the prices for raspberries and the prices for apples, we have the price difference between food items. So the mean price across all months, which is, as I said, the dashed line here, for raspberries is relatively high compared to the mean price of apples. But on the other hand, we also have price variation in terms of price changes within food items, but over time. So here we see that the price changes for apples over time are relatively small. And in contrast, the price for raspberries changes a lot over time. And in this basic mixed effects model, which we just saw before, so it is assumed there that there is no difference in the effect of price differences between food items and the effect of price changes within food items over time on food waste. So we have just an average estimate. But yes, to account for potentially different effects on food waste of price changes within food items versus price differences between food items, we additionally employ an extended model because we combine the mixed effects model with an in-between model to distinguish these two types of price variation. And yes, to capture the effect of price differences between food items, we use the food item specific mean price across all observed months, which is by definition the same for all observations belonging to the same food item, irrespective of the months of food waste observation. And then we also, yes, right here. So I explained the coefficient. So this beta B9 coefficient represents the corresponding effect of food price differences between food items and indicates, we could say, how the food item specific mean price affects the food item specific mean avoidable food waste. So this is the effect of the price difference on the mean food waste level of the corresponding food item. And on top, we have the monthly price deviation from the corresponding mean price of a food item. So this coefficient, beta W9, represents the estimated effect of food price changes within food items and indicates how, on average, within food item change in food price is associated with the within food item change in avoidable food waste. So this kind of model allows us to distinguish these two kinds of price variation. Okay, so we now turn to our results. So first we will have a look onto the basic mixed effects model without differentiating the two price effects. And this is the model here on the left side of this table. And at the top here, we have the fixed effects and then the random effects here. With respect to the fixed effects, so first of all, we find a significant negative effect of higher age. And this is actually also in line with previous studies. So older generations were found to be less wasteful because they might have experienced poverty or food shortages in post-war periods. And also, we find a significant negative effect of higher education. And this might be explained by better educated households having more knowledge on how to appropriately store or efficiently use food items. And yes, then with respect to the variables referring to the period of food waste observation, we have a negative effect of the year 2020 compared to the observational period 2016-17. And also this is in line with previous studies that found that the COVID-19 pandemic, which was back in 2020, and also like the corresponding containment measures of COVID-19 had a negative effect on household food waste. So this was also an expected effect. And in addition, in all summer months from June to September, the food waste amount was also found to be significantly higher than in the reference months of January. And also this appears plausible due to greater perishability of food items in higher temperatures. Okay, so last but not least, we now turn to the food price effect. So in this basic mixed effects model, we estimate a significant negative price effect on fresh fruit and vegetable food waste. However, as you can see, we found the fruits and vegetable food waste to be fairly inelastic in response to prices. So a 10% higher food price is associated with 1% less food waste of the corresponding fresh fruit or vegetable food item. But yes, when we turn to this in between mixed effects model where we distinguish the two kinds of price variation, then the picture somehow changes. So first of all, we can see that the estimated fixed effects here on the right side of the table are more or less similar to the basic model, but the price effect is disentangled. So we can see that this effect of price differences between food items, which was captured by the mean price over all months, is highly significant and much greater than the general price effect in this basic model. So according to this within between mixed effects model, the price or a price difference of 10% between food items is associated with 7% less food waste from the more expensive food item compared to the cheaper food item. And in contrast, the estimated effect of price changes within food items, but over time is actually close to zero. This would mean that a food price deviation from the mean price is not associated with significantly less or more food waste from the corresponding food item. So this result may seem surprising. However, yes, when we think of our example of apples versus raspberries, it is actually maybe easy to imagine that it might be the case that even if the prices of apples, which is a relatively cheap food item, when they go up in a certain month, that these cheap apples are still handled with less care and wasted more than the relatively more expensive food item like raspberries. So, okay, we can summarize that we find a significantly negative but rather small general food price effect, and that according to our an extended with in-between mixed effects model, that we can attribute this price effect to a more substantial effect of price differences between food items. Um, and a rather neglectable effect of food price changes within food items over time. But yes, as I already said in the beginning, one has to keep in mind that our study exhibits some limitations, most severely probably that we do not have data on food purchases and food prices actually paid by the households for the food items. And yeah, that we are just able to investigate the price effect for fruits and vegetables only. And yeah, these limitations prevent us from deriving final conclusions on what our results imply for food policy. And I think that future studies with improved data sets are needed to investigate whether our findings are confirmed and whether they are transferable to other food categories and whether the findings also hold across other food categories. So, for example, if we compare fruits and vegetables to animal-based products, for example. But yes, so what should you take home from this presentation? So one thing is that a distinction between kinds of price variation. So for example, the distinction between the effect of price differences between items and price changes within items, but over time can lead to important insights. And moreover, you should take home that the effect of food prices has so far been an understudied aspect of food waste research, and that empirical research on the food price effect on food waste is needed for the efficient design of future food policies, like, for example, this optimal value-added tax rate on fruits and vegetables, so that when we can align these kind of price policies with the goal of reducing food waste. Yes, that's actually all from my side. So thank you very much for your attention. And yes, I'm looking forward to the discussion and to your thoughts.
Great, thank you. That was very interesting. Alejandro's got a question in the box, but go ahead and unmute yourself, Alejandro, maybe. Oh, okay. I'll read it for you. So, he wrote, if promoting a frugal mindset, a conscious philosophical choice, is impractical, does the benefit of reducing food waste through higher prices outweigh the public health of decreased fruit consumption?
Sorry, I didn't get the beginning, but I can try to read in the chat.
Yeah.
Um, I have never heard frugal mindset, but yes. Does the benefit of reducing food waste through higher prices outweigh the public health cost of decreased food consumption? Yes, this is a good question. And I think we can't say that we should definitely yeah, go for higher food prices, for example, to reduce food waste. And I think that we can't for sure state that one goal is more important than another goal, but it would indeed be interesting to see whether such a reduction, for example, in value-added taxes would lead to more consumption of fruit and vegetables, and what are the health costs involved by this policy. And then it would be interesting also to see what are the greenhouse gas emissions we can reduce and how are they related, so that we can maybe distribute some economic costs or compare the economic costs of both policies and see what the best answer is. But of course, it shouldn't be regressive. So, of course, always like with food prices, we have to keep in mind that especially, yeah, poorer parts of the population would be hit it harder by these policies. So yeah, it's a difficult answer to or a difficult question to answer, definitely.
I have a question related to that. So Europe is a little different, although it is moving the direction of the US. So in regards to this bad thing. So one of the problems in the US is that bad food is actually less expensive and good food's more expensive. So related to that, to what you just said, I mean, wouldn't that have kind of a negative consequence as well?
Yes, definitely. Also, if you see it in relation to other food categories, as I said, I think we have to also consider what such a policy might imply for the relative prices compared to other food products, of course. And for example, I would have also liked to investigate the effects for animal-based products, which are known to be more carbon intensive and rather unhealthy or less healthy compared to fruits and vegetables, but also like, for example, for soft drinks or sweets or fast food. So you could also think the other way around. What if we have a meat tax, for example? What would this imply for food waste? Would a meat tax also lead to less food waste? But unfortunately, with this data, we didn't have detailed information on the meat, and we couldn't match the meat food items to meat prices. So therefore, we couldn't explore this research question. But I think it's yeah, a good idea to also think the other way around. What if we have higher food prices for unhealthy or very carbon intensive food products? And would higher prices not only lead to healthier consumption, but also to less food waste within these food categories?
Yeah, that would be interesting. Yeah.
Yes, definitely.
Any other questions or comments? I know I have a few, but I'll give other people a chance. So while we're waiting, I may have missed it, but I didn't notice the income variable
Ah,
for.
yes. Yeah, true. I forgot to mention it, and that's a different, yeah, for sure, a limitation of our study because the income information wasn't available to us. So we just had the education variable, and of course, education might capture some of the income effect, but nevertheless, of course, prices and income are super closely related. And it's yeah a huge disadvantage that we do not observe the income data and that we cannot explore yeah the mechanisms related to income. This would also be interesting, especially as I said, when we expect taxes to be regressive, then it would be important to also control for income. Yes.
And some of your findings I thought were interesting. So, for example, I jotted down some notes. There was seemed to be more food waste in the summer, and
Mhm.
if I read it correct, or maybe I'm interpreting incorrectly on this one, and more in rural areas as well. Um, I know you had urban, but maybe I'm interpreting that just to in my own brain. But so why do you think that is? Is in the summer because of preserving food, or just that there's more of it and people are, you know, easier to throw it away?
Yes, actually, so with urbanity, it's just a marginally significant result. So I do not have a clear explanation with respect to this finding. But with respect to the summer months, so there are also studies reporting that foods are, of course, or the perishability of foods is higher during the summer months due to the higher temperatures. And I think that makes sense. And also that people are on holidays, for example, and forget about their stuff in the fridge. That might also be, or that might also have an effect. So that these might cause these positive yeah, effects of the summer months on the food waste amount of fruits and vegetables. And also that it might be that more fruits are consumed during the summer. as I said, this is unfortunately also a limitation of our study that we do not observe food purchase data. So we do not, or we are not able to compute food waste shares. Just we are able to look at the absolute food waste amount.
And lastly, with the the older group of people, as they
Yes.
get older, there's less waste. Um, does and I don't know what kind of programs are available there, but is there like assistance programs for seniors to purchase food, or is it just that they just have such limited income they're going to watch it much closer?
Mm-hmm. Yeah, so in the literature, this is also reported that yeah, older respondents incur less food waste, and there it is interpreted, or yeah, they discussed that this might be related to the post-war period, which they lived in, and where they came across food shortages, so that the evaluation of food products is higher. And also, I could imagine that also the opportunity costs of time for yeah, doing like food planning and preparation is lower. So because they have more time than people working all day long, and maybe it's easier for them to plan their meals. So that might also have an effect on this negative effect for older people, I guess.
Was that one of the questions in the survey or uh, diary of like time put in the food preparation?
No, unfortunately not, but that would have been interesting, definitely, to see how much time someone spends on planning food purchases, but also like meal preparation and so on and so forth, and yeah, having yeah, or how much they invest to avoid food waste, but this wasn't covered in the questionnaire.
Anybody else? I took up a lot of time, sorry. It was interesting.
Yeah, I think there was one more message in the chat, but I couldn't open it yet.
It says food waste often re-enters the circular economy in the form of compost.
Yes. Yes, of course. If it does, then it's maybe not too bad, but still there's a lot of resources which went into the production of food, like water, but also energy, and also the calories are wasted. So, and yeah, but it's also good to consider where the food waste goes, because not all households put it to the compost, others flush it into the toilet, and others just put it in the general waste, and others give it to pets. So, of course, you can also think along the food waste chain, like the steps afterwards. But yeah, we weren't able to control for that.
All right. Any other questions or comments? No, I'm not seeing any. So, Vicky, do you have any last comments you'd like to make?
Yeah, I just, so if some of you do food waste research, I would be very curious to see a food waste study which has like food purchase data and food waste data. I think that would be a great advantage to, yeah, really also based on a demand system, being able to estimate own price and cross price elasticities. I think that would be super interesting. But yes, so far I think it's an understudied aspect, and let's see what the next years will bring in empirical evidence. But yes, that's all from my side. Thank you for your attention and for coming.
Well, thank you. It was very, very interesting, and we really appreciate you taking time to present today. So, thank you so much.
Yeah, thank you. Have a good afternoon.
Bye, everyone.
Bye.